Okay, so Nanda's given us a really nice talk about the design framework. I'm now going to talk about how we've then applied that to our case study of avian influenza in the UK. Just to put it in context, at APHA we're involved in work package 2 mainly, and this is the early detection of exotic, new or re-emerging disease. And part of our task is to illustrate the use of the framework by designing and assessing the performance of different surveillance systems for selected early detection risk scenario diseases. And as I said, at APHA we're doing avian influenza. So what I want to talk about today is how we applied the framework to document our avian influenza surveillance. And the aims were really to test the framework. We're still at quite an early stage, but we want to try and identify gaps, problems, further development needs with the framework. Also identify areas where we need to collect more data for our case study on AI surveillance, and identify potential areas where we could start assessing the performance of different surveillance approaches. And finally look at where perhaps we can add in additional tools, but I'm not going to focus on the tools at this stage in today. So just to give you an overview of what we do in the UK for AI surveillance, we have 3 areas. The first is a risk-based serological survey in poultry. This is to meet EU regulations, and as I said, this is risk-based, so we target poultry holdings within high-risk counties in the UK, and this is based on poultry density and wild bird density, and then within this whether they're free range, whether they have what species they've got on the holdings, and proximity to water bodies. The aims of this are to detect low-path H5 and H7 in chickens and turkeys, and low-path and high-path H5 and H7 in domestic waterfowl. The second area we do surveillance is the avian influenza wild bird survey. There are 2 components to this. The first is a risk-based patrol of wetland sites and wild bird reserves carried out by the wardens. And they look for dead birds, and then we'll submit those. The second is reporting of high mortality events, so where 5 or more dead birds are found anywhere in the UK by the public or wardens. They have to be submitted, and the idea there is to detect high-path H5N1 in order to inform our risk to poultry. And finally, the third component is our passive notifiable avian disease surveillance in poultry, and that's what I'm going to focus on today. The aim there is to detect notifiable H5 and H7 in poultry. So going back to the framework, which Nanda's talked about in detail, I want to talk you through how we've used the Excel mock-up tool to document our AI surveillance. So it starts with describing your surveillance system, and here you enter your hazard. I don't know if we've got a pointer here. Rather than just avian influenza, we've tried to be a bit more specific and talk about subtypes and what exactly our surveillance is aimed at, and I've just covered that in the last slide. Also, the surveillance goals, so here we're looking at early detection. The geographical region covered. It's a bit confusing in the UK. Some of our surveillance is aimed at UK-wide, so that's England, Wales, Scotland, Northern Ireland. Some is just GB, so not including Northern Ireland. So we document that here as well. One area that's quite important for early detection, and is a kind of work package specific input into the framework, is the risk of introduction. So what's the risk of introduction into the country? And here you can specify whether it's low, medium, high. I put low here, but actually in the UK, risk of introduction is considered low to medium at the moment. And linked into this then will be a whole set of tools that will give the user advice about how to estimate the risk of introduction, and also how to carry out risk assessments and look at transmission pathways and inform later stages of the framework. And then still at the system level, we think about risk factors. So for avian influenza, we're looking at, so firstly, population risk factors, poultry density, wild bird density, proximity to water bodies, also temporal factors. So we're thinking in the UK, the main migratory seasons for the high-risk wild bird species. Herd level factors, again, proximity to water bodies, high bird densities, production types of farms, outdoor farms, and farms with high numbers of movements, and then also poultry species, because of clinical reactions and susceptibilities. Because we're generally dealing with the epidemiological unit is the herd or flock, we didn't have any animal level risk factors here. And then we go on to designing our individual components, and whereas before I was describing all our surveillance, this is just looking at the passive surveillance we carry out for all notifiable diseases in poultry, which is just Newcastle disease and avian influenza. So then we narrow down to geographical region covered by the passive surveillance, which is GB, target criteria, because it's covered under legislation, all domestic poultry are covered. The framework also asks us to think about the percentage of the population covered, so that if you're not covering all the population in this component, you can think about where else you might cover it elsewhere in your surveillance design. I think for active surveillance, you can estimate this based on your sampling frame and your demographic data. For passive surveillance, I could put in 100% here, that we cover 100% of our population, because that's what's in the legislation. You know, all poultry owners must report notifiable disease, but actually we've gone into a bit more detail and we've been a bit more cautious. I'll talk about this more later. And then particularly important for early detection, passive surveillance, is how you define a suspect case, so how your notifications arise. So our definition in the UK is based on clinical disease mainly, mortality and morbidity, and some production factors. If the farmer notices that his birds are ill and egg production has dropped. The obligations, I'm not going to go into all the legislation. So the notification procedures, what will happen is the farmer will notice that his birds are ill. He will call his private vet. And the vet will come out and have a look at the birds. He'll then make a judgment call on whether it's likely to be notifiable disease or not. If he thinks it is, then he will call the local APHA office and talk to the duty vet there, and they'll have a discussion over the phone. If they can't rule out notifiable disease based on that discussion, the duty vet will then inform the farmer and the vet that they must not move any birds on and off the site, and he will go out and visit the farm. He'll inspect the birds, look at records. If he can't negate the case based on clinical signs, then it becomes an official report case, and restrictions are officially placed on the premises. Last May we implemented testing for exclusion. So if the private vet thinks that disease is it's notifiable disease is fairly unlikely, then they can ask for confirmatory testing, but without restrictions being placed on the farm, and that's at the farmer's cost, not the government. And this is all laid down. We're documenting at the moment. It's all laid down in our notifiable avian disease control strategy for Great Britain. The testing protocol, again, because I don't have a lot of time, I'm not going to talk too much about that. I think confirmatory testing for avian influenza is fairly well established, and it's just a case of then going through and documenting what tests are used, if you're doing a first test and then a second test, and again. So some of the questions in the framework weren't relevant for us because they're maybe not relevant for passive surveillance. You can go through and fill them out if you can. I mean, they're there. But like study design, sampling strategy, they're probably more relevant for active surveillance. And likewise, I don't have time to talk about the other sections of the framework. So this is how data is collected, collated, analysed and reported. And what we wanted to do then was look at our documentation and go to the redesign section. So perhaps if we knew our surveillance had issues with sensitivity, what advice could the framework provide that could help us redesign in order to maximise sensitivity? And Nanda's actually shown this, so you can see this is our documented surveillance, and then against each part there's a bit of advice about sensitivity. So what did it say? Well, there were lots of areas where sensitivity is affected by the choices we made. Some aren't relevant to passive surveillance, and not all redesign options were practical or realistic for the purpose of our case study. We want this to be a useful exercise for policymakers, for epidemiologists. So, for example, the testing protocol, there's a lot of advice about sensitivity around the testing protocol. But I think for us to go in and give advice about changing the tests they use for avian influenza, that would just not be practical. So I've just highlighted the main areas that have been highlighted for further investigation. So there's lots of advice about risk targeting, where you can improve your sensitivity through risk-based surveillance. I think that's a whole talk in itself, so I won't talk about that more. Coverage of populations and definition of a suspect case, I'm going to talk about in a minute. Actions upon suspicion, so whether restrictions are placed or not. I've talked about exclusion testing, and that's kind of one area where work's being done on that, and enhancements as well, how you can enhance your surveillance through financial rewards or training awareness. Okay, so just briefly, one area that was highlighted where we could improve our sensitivity was the coverage engagement. And there's a performance attribute for coverage as well, which is linked to sensitivity. So when you're going through, I think it's important you look at more than one attribute. But we know that some sectors are not well covered by passive surveillance in the UK. We think the commercial holdings, company holdings are. We know that a high proportion of specialist poultry vets will submit samples to APHA. But we also know that other sectors are very poorly engaged. So the non-commercial sectors are seasonal producers, the holdings with less than 50 birds generally, and also the game bird sectors. And there's a lot of uncertainty about the probability of reporting in these different sectors. What we want to do for our case study is to design a simulation model. Adam's working on that at the moment. And what we can do is we can redesign some aspects of the surveillance and then use the simulation model to look at the effect that'll have on the sensitivity or the timeliness or other attributes. And also there's a potential here to carry out further analysis on submissions to APHA and really try and understand a bit more about where the areas are that we have poor engagement with the producers. And the second is disease suspicion. So at the moment, a farmer will generally report based on clinical signs or high mortality in his flock. We think high path AI is quite likely to be detected, especially in chickens and turkeys, but the situation with low path in chickens and turkeys and high path and low path in ducks and geese is a lot less clear, where there may not be obvious clinical symptoms. And what we want to do is look a bit more closely at whether we can introduce monitoring of production indices, so egg production, feed, water intake, that may increase the likelihood of detection for these low path viruses. And some work's been done on this in the recent outbreaks, looking at whether premises linked to the infected premise might have been infected by looking at egg production data. So there's quite a lot of interest in this. And again, this is something that's testable using a modelling approach, and I think would be quite nice to look at. So just to finish up, the next steps we want to further document our AI surveillance system, look at the active components and the wild bird surveillance, and also look at other systems for a variety of hazards. So for just generally for early detection, look at passive, active, sentinel and vector-borne systems. And then we're going to go on and develop this AI case study a bit further, bringing in the simulation model and other tools to look at the impact of redesigning components. Thank you.